Hello everyone, my name is Andrew, and today we'll be tackling the USACO problem of January of 2020 called Photoshoot. Now this problem is in the Bronze Division. It's the second problem. Let's get right into it. Alright, so if we just start reading, we can see that Farmer John is lining up his N cows, numbered 1 to N, for a photoshoot. Farmer John initially planned for the ith cow from the left to be cow numbered AI. We wrote down the permutation A1, A2, AN. So basically every cow is basically A1, A2, AN on a shaded paper. Unfortunately, that paper was recently stolen by Farmer Nahaj. Luckily, it still might be possible for FJ to recover the permutation that he originally wrote down. Before the sheet was stolen, Bessie recorded the sequence B1, B2, all the way to Bn-1 that satisfies Bi equals AI plus 1, for each I is less than or equal to I less than N. So based on basic information, help FJ restore the lexicographically minimum permutation A that could produce B. In permutation X is lexicographically smaller than a permutation Y for some J, Xi equals Yi for all I minus I is less than J, and Xj is less than Yj. In other words, the two permutations are identical up to a certain point, at which Y is smaller than Y. It is guaranteed that at least one such A exists. Now, if you're like me and you're actually competent, so if you're like me, you would think that this paragraph doesn't really make much sense. You don't really know what they're talking about. But if you actually scroll down and look at their input, it's actually quite simple. So they give you N, or in this case 5, and then they give you, let's see here, they give you B. So in this case, it's going to be B1, B2, all the way to N-1. So you can see that this is a length of 4, which is N, or in this case 5 minus 1. And then what we're returning is A, what we're returning is A, which is basically an array of numbers of length 5. And if you just look down here, they have an explanation of why this output is what it is. So in this case, 3 plus 1 equals 4, and 1 plus 5 equals 6, 5 plus 2 equals 7. And you may get confused, but if you just look at these numbers real quick, you can see that every two numbers corresponds to one number in B. So in this case, this is A, and this is B. And so in this case, 3 plus 1 equals 4, 1 plus 5 equals 6, 5 plus 2 equals 7, and 2 plus 4 equals 6. Alright, so now we understand why the input generates the output. We can start thinking about how we're going to solve this problem. Alright, so if we want to solve this problem, it's better to map it out on some workspace. So here I got Zeitboard. Basically, let's just draw out the input and output. See over here, so it's 5, and then 4, 6, 7, and 6 again, and then that turns out to be 3, 1, 5, 2, 4. Alright. So, if we just take a look at this input format, this is just going to be N. So in this case, N is 5. And then 4, 6, 2, 6 is going to be B1, B2, all the way to B of N minus 1. In this case, or what I mean is that this array of numbers is just going to be, the length is just going to be N minus 1, or in this case 4. And finally, this is going to be what we're returning, or A. And it's an array of numbers that basically comprises a bunch of numbers that add up, or every pair of numbers adds up to be a number of B. For example, 3 plus 1 equals 4, 1 plus 5 equals 6, 5 plus 2 equals 7, and 2 plus 4 equals 6. Now, how do we produce A? They don't really give any clues in here. They just tell you about this permutation that I don't think is really relevant to our thought process. But if they say that he's lining up his cows and they're numbered 1 to N, meaning that every cow ID has to be unique and there can't be any repetitions. Basically, there can't be more than one cow of the same number. So in this case, what we know is that if we choose a number to start, then it has to lead all the way back. So for example, what I mean is that, for example, 4, that's it can either be 3 plus 1 or 2 plus 2, and that's it. There are no more permutations unless you want to flip the order of 1 plus 3. So in this case, we have 3, 1 plus 3, 3 plus 1, and 2 plus 2. Now, if we try all of them, we can see that if we try, say, 1 and 3, so in this case, this is not 3, it will be 1. So 4 minus 1 would be 3, and then 6 minus 3 would be 3. So as soon as we see that there's another repetition of the same ID, that's impossible, as they're numbered 1 to n. There can't be any repetitions. So in this case, that's not a case. And if we try 2 and 2, so I'm just going to erase this real quick. If we try 2 and 2, 4 minus 2 is 2, and then that's already another 2. So that's another repetition. So that doesn't work either. So the reason why this one works is because if we say 3 and 1, 4 minus 3 is 1, and 6 minus 1 is 5. 7 minus 5 is 2, and then 6 minus 2 is 4. That's why we get this answer, because if we try basically part of a sum for the first one, and it works all the way through, meaning that every time we subtract our next number from one of the numbers of b, we don't get any repetitions in numbers. If you don't think this is clear, you can comment down below and ask any questions. But essentially what I'm trying to say here is that we only need to calculate a part of a sum of the first number and try every permutation of that number and see how it factors into all of these numbers. And if there's a repetition, we basically break and then we just try the next one. So that's how we're just going to generate a here. Okay, so I've got my IDE open here, and I've set up a new project called USACO 2020 January Bonds. That's how I organize my things. And I created a new Java class within it called Photo. And yeah. So I have added my two BR and PW statements in here in order to read and print out our output. And we can start reading an input now. So if we just take a look here, we can see that the input is just going to be in order of n and b. And that's it. It's pretty simple. So let's go back to our ID here, and then we say int n equals integer dot parse int br dot read line. Int of b is equal to new int. So this is going to be the array that's going to store all the values for b. String tokenizer st, since these are separated by spaces. So therefore we have to use string tokenizer to basically tokenize every single number and put them into this array. So this is a really common method among the USACO community, I believe, in Java specifically. And then we have to import the class. What's wrong with you? Oh, we have to say a new one. Okay, sorry. I had a little stroke there. And then we have to add a for loop in to basically put everything into this array of b. So I is less than n minus 1, or the length of b, and then b of I is equal to integer dot parseInt, as they're written as strings again, and st dot next token. And there we go. So now that we have put in the code to read in our input, we can start getting down to the real cool stuff. So right now all we have is we have n stored as a variable, and then we also have b. Oops. And then now let's just create an array to hold the values of a. And this is what we're going to be returning at the end. Okay, so now that we have our a created, so a is just going to be length of n, as said in the problem. And then we're just going to read in the values of a, and then so we're going to add a for loop here, and like we discussed before on our Zeit board, we only have to go to we only have to loop through the first value of b, as we only have to find permutations of part of its sum. For example, 1 and 3, 3 plus 1, and 2 plus 2. So essentially, we only, the first one is just going to be b of 0, index 0, and that's just going to be the first one. So we're going to loop 4 times, and then we're going to say, oh, 4 minus 1, 4 minus 2, 4 minus 3, and that's going to generate these 3 permutations here. So b of 0, oops, it's I equals 0, no, sorry, 1, I is, so we put 1 here because we can't really use 0 to subtract anything here because it's from 1 to n, not 0. So from 1 to n, not 0 to n. So if 4 minus 0 would just be 4, and that wouldn't work really. So it's going to be I equals 1, and then I plus plus. And then let's just create a variable called j, and let's see here. Okay. Alright, so let's just create a j, and then so j is basically going to be our second loop that's going to loop through the entire array. So what I mean is that here, I'm just going to erase a bunch of stuff here. Alright, there we go. So what I mean was that we have 3, 1, 5, 2, 4, and then we have 4, I believe it's 4, 6, 7, 6. So now that we're just basically getting all the permutations of part of a sum of 4, we actually need to loop through the entire array to basically calculate. So if this is 4, then we say it's 1, and then we have to subtract 1 from 6 and keep going all to the array unless there is a repetition. And if there isn't, that means we return our value and get the result. So in this case, we just have to create a variable to hold the loop that we have for later, as we're going to compare the values compared to iterative values of the second loop. All right. So let's just do this. So let's just create a set real quick let's check whether there's any repetition in the cow IDs. Let's just say nums equals new hash set. It's going to be integer value. Oops. Sorry guys, I'm really bad at typing. And then let's create a variable here. Let's just say create some variables to hold variations of b0 minus I. So if you don't know why it's b0 minus I, again, it's going to be a permutation of a part of sum of 4, or in this case 4 minus 1, 4 minus 2, 4 minus 3, and this we're going to end up with 3, 2, and then 1, and then we're going to compare them with all the parts of 4 and see whether there's repetitions down the line. And so we're going to create some variables here, and then we're going to set, let's just say int num equals I. So we can't really reference I from here, so we actually have to create a variable to store it. And then let's just say, let's just add it into the set, and then let's just say a0 equals num. Alright, so now that basically we've added the first value into the set, we can see whether we can start running through the rest of the array of b and check whether there's any repetitions. So if you don't know what we're doing here, basically we're just adding the first value of that we get. Basically either it's 4 minus 3, 4 minus 2, 4 minus 1 into that array, and then into that set, sorry, and then we can compare whether a value already exists in that set, and then just iterate throughout the array and check whether there's any repetitions. So in this case, j equals 0. So we defined j earlier, so we actually don't have to do it again here. I plus j plus plus. We're just looping through b right now. Scroll down a bit. Alright. So let's just say int num2 equals to b of j minus num. So if you don't know what this is either, basically it's just going to be 4 minus 1, 4 minus 2, 4 minus 3, basically just a part of a sum of the first number of b. And then, so now we can check whether this set contains it. So nums dot contains nub2 or nub2 is less than or equal to 0, as we can't have any negative cow IDs, so we always need to check for that. Not nub2, nub2. Alright. So, if there's a repetition, then we just go to the next value. Here, I'll make it more clear for you guys. Basically, from what we discussed before, here, I'll just do this. Actually, that's not gonna work. Yeah, guys, I'm not really flawless. I make mistakes too. Everyone makes mistakes. It's okay. You just gotta learn from your mistakes. Next time will be better. Alright. So basically what I mean is that if we have 4, 6, 7, 6, and then 3, 1, 2, 4. Basically, we break as basically, let's just say that instead of 3, we try 2 first, and we get so 4 minus 2 is 2. And as soon as we see that 2 already exists in the set, so these are equal, then we can't have any same cow ID, so we just break out the loop, and then we I have no idea what I just did, and we just simply break out of the loop, and then we move on to the next value of b and compare. So in this case, it's just going to be arrays dot fill a. So we're just basically clearing out as it's pretty much futile if we just return it. Not a of zeros. So we're basically filling a with a bunch of zeros. So in this case, a would look something like this. And then after we do that, we just break out the loop and continue to the next one. So let's just add some comments here to say why we're breaking. So we break if there is a repetition of cow IDs, as all IDs are unique. So else basically saying that it doesn't exist, and it basically goes along with the harmony of things. Then we still need to basically increment a and say num2. Basically store the value into the thing that we're going to return, and then num equals num2. Basically we're incrementing num by num2, so we're moving to the next one. So it's so basically we're just 3, 1, 5, 2, 4, 4, 6, 7, 6. And basically, what we're just doing here is that we're incrementing nub. So right now, if we just try the test case here and we say 3, and then we get 1. So now num has to become 1, because that's where we're compared to the next one. And then 7 minus 1 would be so 6 minus 1 would be 5. And then we have to compare, and then num has to become 5, and then we have to compare 7 to 5, and that would be 2, and so on. So, and then num equals num2, and nums dot add num2. Num2. I don't know why I keep on doing num. I think it's a bad habit. So in this case, if nothing is repetitive, we increment nub, so we can get difference of next value. And if we just scroll on here, after that we basically just break out the loop if j equals n minus 1, or the loop is finished, and we just break it out. break out of it. So now the loop is finished, we have a full array of A, and now we can just return it. So we can't really return an array as a whole, so we actually have to create a loop for it. It's kind of bad, but you know, it works, and if it works, it's fine. If you're minimalist like me, you just like things being simple and working. So we actually have to do n-1 because these are separated by spaces. So we can't really code it so that the last one is not separated by a space in terms of the loop. So let's just say space. Okay, and then that's pretty much it. And then we just print the last one. So in this case, it's going to a-1 since indexes are starting at 0. Print line, pw.close. So we close our two running methods right now. And yeah, so that's pretty much it, I believe. So now you can just plug it into your USACO website and let's test it. Alright guys, I'm here at the USACO website, and let's just find my file real quick. It's just going to be on my desktop. USACO, desktop. And then I believe it is, oh, it's right here. Okay, so it's 2020 RONs, source, and the photo, and we can just try it out. So it's grading right now. Oh, we have an error. Oh, it's simply just a typo. Line 20. There we go. Let's try it again. Normally, I would just run these locally, but since I'm doing a video today, it's better to see how the USACO website grades it. Oh, shoot. Oh, I see. So we got the correct output, that's nice, but in this case, we actually have to not do new lines here. So let's do this. Let's see here. Yeah, so it's not print lines, just print. That should work. Save it. Go back. Submit it again. Cross your fingers for good luck. We got 2 test cases. 6, 10. Thank you guys for watching this video. I hope you enjoyed and learned something new today. That was 2020 USACO January contest bronze problem 2 Photoshoot. I hope you enjoyed this walkthrough. I hope if you enjoyed, please consider subscribing. I put a lot of time into these videos, and I don't really get anything in return except suggestions or compliments from you guys. So thank you guys for watching again, and I'll see you in the next video. These videos will get better slowly. I'm trying to improve my channel over time. So thank you. Thank you guys. I'll see you later.